Hey y'all, welcome back. Today we are trying to understand what a rate of speed is. So we talked about different rates. Primarily we focused on speed, which is a comparison between distance and time. A rate compares two different types of units. Speed, for instance, like I said, compares distance to time. So some examples of speed units would be feet per second, miles per hour, kilometer per minute. Really, any comparison between a distance and a time will be a speed. So let's jump into the problems and see if we can't figure out how to work these out. Number one says, driving at a constant speed, Reggie travels 900 kilometers in 3 hours. What is Reggie's speed in kilometers per hour? So to solve this and other questions that are like this, we'll have to use a little proportional reasoning. We're going to set up a proportion that compares the kilometers to hours, 900 kilometers in 3 hours. We want to say that rate is equal to how many kilometers in 1 hour, right? We want to know what's the speed in kilometers per hour. It doesn't specifically say 1, but if it doesn't ever say, it's going to be a 1. So to solve this, we talked about in class how we can use the cross products property to solve a proportion, otherwise known as cross multiplication. And the way it works is you multiply each numerator by the other denominator and set those products equal to each other. So 3 times x is equal to 900 times 1. So 900. And then we can solve this equation using our properties of equality, divide both sides by 3, and we get x equals 300. So 300 is our x, and so that is our speed in kilometers per 1 hour, 300 kilometers per hour. Number 2 is a multiple choice question. It says Reggie, we're still dealing with Reggie here, can run 330 feet in 30 seconds, which shows Reggie's rate of speed. So just make sure speed is a distance per time. So I'm looking at all these. I see distance per time. Reggie runs 300 feet in 30 seconds. There's really not much to say about this. The answer is C. Now, they may have asked, you could imagine a similar question might be something like, well, how many feet per second would that be? In which case you divide both of these by 30 and get 11. So this would be the same thing as saying 11 feet per second. It doesn't ask you to do that, but I could definitely imagine a problem that would. Number 3 says the fastest train in the Western Hemisphere is the, man, you guys are going to get me on this pronunciation. I'm not really sure. I'm going to go with Acela Express. Is it Acela, Acela? I don't really know, but I'm going to go with Acela. Anyway, on a route between Boston, Massachusetts, and New Haven, Connecticut, the train regularly travels at 135 miles in 60 minutes. So what is the speed in miles per minute on this portion of the route? So if we're trying to convert to miles per minute, that's however many miles in 1 minute. So we'll set this up similar to number 1 as a proportion. 135 miles is to 60 minutes as how many miles is to 1 minute. We do miles per 1 minute. When we go to solve this, we're going to use the cross products property again. So 60 times x is, well, just 60x. 135 times 1 is 135. And then we'll use our properties of equality here, specifically the division property of equality. Divide both sides by 60. We get x equals whatever that equals. I'm going to have to type that in just to make sure I'm getting it right. 135 divided by 60 gives me 2.25, and that's going to be measured in miles per minute. Make sure that you're keeping track of your units. It can be tempting to just once you get that x equals to go ahead and box your answer. But this whole unit is about measurement. And so I really want to emphasize the importance of keeping track of your units, because 2.25 miles per minute is not the same as, say, 2.25 kilometers per hour or meters per minute or anything like that. Number 4 says Damien reads 21 pages in 1 hour. How many pages can he read in 3 hours? So we know he reads 21 pages in 1 hour. And we are wondering how many pages, X pages, can Damien read in 3 hours? So, usually you think of speed as a distance per time. This is still a rate. It's not really a speed because you're not traveling a distance, but it can still be solved the same way. So we'll use that cross products property, multiply 21 by 3 and 1 times x. Now 1 times x is just x. So this is actually going to be a little bit easier than the past couple of problems. 21 times 3 is 63, and there's nothing really to solve here. It's already solved. So 63 pages in 3 hours. Number 5 says a cruise ship travels 176 miles in 8 hours. What is the ship's speed in miles per hour? So 176 miles in 8 hours is equivalent to how many miles in 1 hour? Using the cross products property, and I'm going to get tired of hearing me say that because most of these problems are worked the same way. We get 8x, where x is our answer here, equals 176 times 1, so just 176. We'll divide both sides by 8. And don't feel bad about using the calculator here. Even Mr. Schuler's doing it. I get 22. So x is 22. And let's not lose track of our units here. The ship's speed in miles per hour is 22 miles per hour. Number 6 says Ling drove at a speed of 45 miles per hour for 225 miles. How many hours did she drive? So Ling was going 45 miles per 1 hour. So 45 miles in 1 hour is equivalent to 225 miles in X hours. So this is actually the first time that X has appeared on the bottom. Don't let that throw you off. That could happen. It just kind of depends on what you're given and what you're being asked to solve for. We're still going to use the cross products property, and I would recommend, starting with that x, so it starts off on the left-hand side of your equation, although technically it doesn't matter. I just really like having it on the left. So I got 45 times x equals 225, because 225 times 1 is just 225. Now we'll divide both sides by 45, and that is going to be our answer. Let's see here. So x, well, I'm going to use the calculator. I was trying to get that in my head, but it's just not happening today. It's just 5, so 5 hours. Number 7, a plane flew 3,100 kilometers at a speed of 775 kilometers per hour. How many hours was the flight? So we'll start with the 775 kilometers per 1 hour. And say that that's equal to, or equivalent to, the ratio of 3,100 kilometers to how many hours? Once again, we'll use that cross products property. 775 times x is equal to 3,100, just from this 3,100 times 1. We will divide both sides of this equation by 775 to get our answer. 3,100 divided by 775, I'm getting 4. Wow, all these are working out pretty nicely. So x is 4 hours. Number 8. Looks like we got a pretty short homework tonight. Andrew drove 6 hours to get to his uncle's house. He drove at an average speed of 48 miles per hour. How far did Andrew drive? Okay, so we're going to start off with that 48 miles in 1 hour. And we want to know how many miles did he travel in 6 hours? 1 times x is just x. Gotta love it when that happens. That means you're not gonna have to solve anything. 48 times 6 is 288. So that's it. There's really nothing to solve there. It's just 288 miles. This is I'm just going through it so fast, just kind of on autopilot here. Didn't even realize it was multiple choice. Our answer is C. Number 9 says Marguerite sailed 4 hours on Saturday and 3 hours on Sunday. Okay, so I'm probably need to keep track of both those 2 different days. Each day she sailed at a rate of 11 miles per hour. Okay, so A, how many hours did she sail? Oh, altogether. I guess we could just go ahead and add it up. So this is a total of 7 hours. And it does say each day was 11 miles per hour. So it's going to be the same on both of those. So let's start with that 11 miles per hour. And we want to know how many hours did she sail? Wait a minute. How many hours did she sail? Oh, well, we already answered that question. I was thinking it was going to ask how far did she sail, but that's part B. So this is going to kind of walk us through it, actually. So yeah, total 7 hours. Let me just rewrite this. So to get the total number of hours she sailed, we're just going to do 4 plus 3. Okay, so 7 total hours. And then now, this is the question I thought we were going to answer. Part B says, how far did she go? So if she went 11 miles per 1 hour, but actually traveled 7 hours, we want to know how many miles is that? So y'all should know the drill by now. We're on problem number 9, doing the same thing 9 times. X times 1 is X. 11 times 7, I can do that without a calculator, 77. So we get X equals 77 miles. Number 10, and our last problem for tonight. Mason skated 21 miles in 2.5 hours. Bianca skated 22.5 miles in 3 hours. Who skated faster? So we want to know what the miles per hour is for each one of these so that we can compare them, sort of compare apples to apples here. Okay, so let's find their rate separately. So here's Mason. Here is Bianca. We'll do them separately. So Mason did 21 miles in 2.5 hours. And we want to know what is the miles per hour on that. So basically, we're trying to force the hours to be 1. For Bianca, she did 22.5 miles in 3 hours. And we want to know what is her speed? X miles per hour. I'm actually going to move this over so I have a little bit more space. Well, no, I guess it's not going to let me do that. That's all right. All right, so for Mason, we've got, I guess I'm going to have to write kind of small here. Just stick with me. You know what? Maybe I'll zoom in here so you can see it a little easier. So 2.5 times X. All right, we're going to use that cross products property and multiply these 2 products, or these factors rather. So 2.5x equals 21 times 1 is just 21. And then so we need to divide both sides by 2.5. So 21 divided by 2.5 is 8.4. And that's going to be miles per hour. So that's how fast Mason was going. Okay, that's not our answer because the question is who was going faster. So, instead of writing x here, no, that's fine. We'll just go with it. For Bianca, I'm going to do the exact same thing here. 3 times x equals 22.5 times 1. So we have 3x. Oh, can't see that. Let's bring that over. 3x equals 22.5. So if I do 22.5 divided by 3, I'm going to get 7.5 miles per hour. All right, now let's take a look at both of these. Get both of them on the screen here. And so the question is, who's going faster? Well, you can see Mason is going 8.4 miles per hour. Bianca is going 7.5 miles per hour. So our conclusion here is that Mason is going faster. So Mason skated faster. And that wraps it up for tonight. This is going to be the last lesson for this unit. This is another short unit. So next class we'll do some review and take a test after that. But as always, if you need any help with any of these problems, or if something's just not making sense or clicking with you, please let me know. I'm easy to find. Y'all have a great night. I'll see you next time.